All right, welcome to Fluxy Lightning. I'm Mike Tutlow. I work at Bracket Labs. I'm a co-founder and lead developer there. Bracket Labs was founded solely to be a Salesforce app vendor selling native apps on the Salesforce App Exchange. What that means to you guys is we do a lot of Salesforce dev, and we wind up doing a lot of kind of more bleeding edge Salesforce dev, and I'd like to share what we've learned doing this. So I'm going to be talking today a lot about state management and Lightning components. It kind of came from stuff I was hearing in the community as well as within our own team. Common questions I heard with Lightning component development are things like, how do I tell the parent something happened on the child? How do I tell a sibling something happened to another sibling? How do I add and delete a bunch of components with JavaScript through a controller? Am I passing a component by value or reference? Am I even passing an attribute by value or reference? And I kind of want to take a step back and think about how we could avoid a lot of these questions and make the developer experience a lot simpler with Lightning components just through design patterns. So when you really come down to the problem with what we just spoke about and even intermittent bugs in front-end applications in general, the problem is always application state. Something has gone wrong with your application state and it's changed at one point and it's producing this intermediate issue. Or you're just confused maybe about why the application is maybe displaying something you think it shouldn't be. So first, let's describe state. State can be data you load from the server. State can be changes you've made on the client side that are in flight to the server. And it can also be newly modified data coming down from the server. All of that combined together makes up application state. Stuff we all know, we're just kind of defining it here so we have a base of reference. So we talked a little bit about what is state, how do we change state. Client-side storage, so maybe you scroll through some pages and you don't change anything on the server. So when you reload the page, you're going to have to redo all those state changes you just did. A persisted change, think about like you're setting recently viewed accounts or something. That's something that persists a change to the server and will reflect in your client-side application on a refresh. Or there can be even background actions. Think about the streaming API. Think about polling for changes. If you find a change, you need to apply it to your client-side state. There's a change. So why do you change it? You have to. User interactions, server actions necessitate the change of the state to reflect in the front-end UI. So the question is, okay, where do I hold state? Does every component have state? They can, but maybe you don't really want that. So the solution that we've seen throughout front-end dev in general, and I'm trying to bring back to Lightning components with this presentation, is to keep all of your state in one giant state ball at the very top of your application. So the benefits of this are there's one source of truth for what's going on in your application. It's all in this one big object at the very top. What that gives you is you're able to debug a lot easier because there's only certain things that hit that big state ball at the very top of your application. It also helps you share data between components. As your application grows larger and larger, you may find, in your original proof of concept, this component didn't need to talk to this component. But as you get further and further down the product line, they're all interacting to some extent. You may be showing pending changes, something like that. I've also found it's helpful when you have large teams working on the same code base. If it's very explicit what you're doing, it may be worth it to type the extra lines of code to make it very explicit. It just makes everyone a lot more clear on what's going on in the application. The cons are, if you have one source of truth, you change a lot of your thinking. A lot of times you find yourself pulling what you initially think state should be living on a child up to a parent. And figuring that out predictably in your head is a little bit of a change for every developer. And even if you're seasoned in it, you still find yourself moving state up eventually. You also have to pass more stuff down the component tree. So as you're changing state at the very top, you're also passing attributes down to components, and you're passing those all the way down the component tree. So there's a little bit of a trade-off on what you're doing. You're making it more expressive and easier to follow, but you are adding lines of code. So how do we do this effectively? So essentially, every app or component has a very top-level smart component. What that smart component does is it goes out and looks for data from the server, it updates data on the server, and it applies pretty much any change to the application state to that one big state ball at the very top. What smart components don't do is complex UI layout. All that's left to the dumb components. So you're really handling XHR transactions, changes to pending application state in your smart component, and you're worrying about UI somewhere else. You still slice these components up into chunks that make sense, but you just essentially say, okay, sidebar goes here, center pane goes here, stuff like that. What do dumb components do? Dumb components do, some of the hard stuff. The UI layout, figuring out what's going to happen when a user clicks something. All of those handlers happen in the dumb components. What do dumb components not do? They don't change state. Only smart components directly mutate state. They also don't temporarily change their own state. So you don't have like an attribute coming down and then you set it and wait for something else to happen up top to reset that. That gets really confusing if you try to go down that route. So let's talk a little bit about our very top level smart component. So we mentioned what they do, data fetching, they tell the dumb components what to say, and they store and handle all application state. So here's an example. We'll go through this code a little bit later, but I just wanted to point out a couple things. We're essentially handling two things in this. We're handling an initialization event. So when this smart component first gets mounted, what we're going to do in that is probably go out to the server and ask for some data. And then we also have a generic event. We'll get into that a little bit later, but that's essentially how our dumb components are communicating to the smart components. So what do dumb components look like? They do a lot of layout. This is where you'll be copy pasting from the SLDS website into your dumb components. And you'll be changing you'll have all of those style classes set there. You'll also be attaching your click handlers, every event handler you have. All the UX work you have is pretty much done in a dumb component. So how do they talk to each other? There's a couple ways you can have dumb components talk to smart components and Lightning components. You can pass an Aura action. An Aura action is a client-side controller method down as an attribute to another component. And then you can enqueue the action and fire it off. It works. I don't feel like it's necessarily the most intuitive way to handle this communication. So you can also communicate with events. Know how we asked the question at the very beginning of this presentation, how does a child say, tell the parent something happened to it? The answer is always events. We're going to leverage that and really organize how we're sending those events. So our approach is going to be one single event called a generic component event. And we're going to provide a key. It's going to be an object, it's going to have a key, and it's going to have a payload. So then we're going to handle that event in something, if you're familiar with Flux or Redux, something that looks a lot like a Flux store or a Redux reducer. So what's our communication flow going to look? Bringing this all together so we're all on the same page. User has an interaction. Let's say they click something. The dumb component fires an event. It goes to the smart component. The smart component figures out what the event is and what it should do. It does a bunch of things. It probably does a server action if it's persisting something. It might do some kind of optimistic update to the UI. It might show a loading indicator. So some of those are asynchronous, some of those are not. Eventually that server-side action will return. The smart controller is going to consume that. The smart component is going to update its own state ball attribute, and that will just flow down to the dumb components as an updated attribute. So let's look at the component we're going to make to demo this. So super simple. We're going to have contacts mapped to an account, the ability to add a contact to an account. Really master detail stuff we find ourselves doing in Salesforce Dev a lot. So what's our smart component? We're going to have the account editor container. So that's going to contain both of those accounts we see there. It's going to contain United Oil and Gas, Edge Communications. It's going to essentially be an array of accounts. And our entire state ball, as we'll see later. And then our dumb components, we're going to break those out again. And we're going to see there's an account detail component. So that would essentially be that, I forget the term for it, the gray background single account container. And then there's going to be a contact detail row. So each one of those rows is going to be their own dumb component. All right. It's on GitHub. This will be at the end on a Q&A thing, but if you're curious about the repo, you can always go look at it. I'm going to jump out now. Okay. Let's do a quick demo of how this works, again, so we're all on the same page. I don't know why I just refreshed Lightning Experience when it's working on the live demo, but that'll be okay. Okay, so you can see we've got 2 accounts in our view right now, and I'm going to demo adding a new account, a new contact to account. So we can see we've just added one. What do we see happen there? We saw a flash. That flash was essentially a loading indicator come up, and then we saw the new row come in. Okay. Let's take a look at some other behavior of this component we've designed. Let's look at Edge Communications. Oh, that's interesting. We closed United Oil and Gas Singapore when we opened Edge Communications. So maybe we had a requirement from our product owner that having all of these open at once is confusing to people. Let's only have one open. So let's step through some code. Oh, I forgot to demo the one thing we're going to step through real quick. You can delete a contact. Same thing happened. Loading mask happened, then eventually it refreshed when the server came home, the row disappeared. So here's our contact row view. That is within an account details view. So you can see that right here. Just iterating over the contacts of the account. Step up one higher. Do this, and you can see we're just iterating over the accounts. So smart component very top, single account component, contact row component. Let's look at what the contact row component does. So totally a table row ripped from the SLDS website with all those classes. We have an anchor here that says navigate to record. We have an anchor, a div here that fires on click. We're going to delete the contact, so that's our X. So we know c.delete contact, that means we go to our client-side controller, we look at delete contact, and we do something. So we want to fire the event to delete a contact, and it's going to get handled somewhere. But right now we're in the dumb component. All we're doing is firing the event off. Then something's going to happen that someone much smarter is going to know about. So we're going to get the relevant info to identify this event. What's it going to look like? We mentioned earlier our event shape. This is the event shape. Notice how simple it is. It's got a string, which is essentially a unique key for every event, and it's got a payload. That payload is an object, blank object. We can put whatever we need to consume in there. It makes this really reusable. So we're going to get an instance of that event. Component, get event, generic event. Name it delete contact event. We're going to set parameters. The action type will be delete contact. Okay, there's our key. Now when we handle it, we know what's going on. And then our payload's going to be more details about this. So the contact ID we would like to delete is the contact ID variable we're getting from the component's attributes. And then we're going to fire it. So what happens when we want to consume that event? So it's going to bubble all the way up to something really interesting called a facet provider. We'll go over that at one point. But essentially what you need to know is at our top level, we're handling that generic event. And we're handling it in our client-side controller here. Oh, wrong file. There we go. So here's our client-side handle generic event controller method. We're getting the payload. We have a switch statement here where we're getting the key that we have. So our action type. What's our action type? For what we just did, our action type is to delete a contact. Let's find out what's going on here. Okay, when it's a delete contact, we're going to run a helper method that's saying helper.delete contact, here's the contact ID, here's every other parameter to this client-side controller method you may need later. So if we look in our helper, delete contact. We're doing a few things here. We noticed our flash with the loading mask. That's component.set v.operation pending. So it's an attribute of the smart component saying a server-side operation is pending. We should do something like show a load mask. Then we're going to do something on the server. So we're going to component.get c dot, where c dot in a client-side controller means the server-side Apex controller. And we're going to set some parameters on that Apex server-side method. We're going to set a callback, so what happens when the server returns with a response. And then we're going to parse it. So helper.parse the account, parse the my account's response. So then we enqueue it, and it eventually comes home. Let's look at what happens when we parse it. We're going to parse it, and notice that this is reused. This is reused in several methods, and we can go over that later, but what that really gets us is the ability to consolidate things that always happen when the server returns with a new response. One thing that could always happen is you clear the loading mask. And then you could also update essentially that one big state ball at the very top of the component or application tree. So that's pretty much how you work through that whole progression. There's a good amount of typing, there's a little bit of thought process, but what you can really see is as you're going through this, it's very explicit what is happening. You're firing an event, you're handling that event, and if you're curious about what event just happened before something messed up, what can you do? You log right here, because this is the only place within your application where you're going to be modifying these attributes. It's pretty powerful, and you can think about way more important things to log. You can think about things like metrics in the event we're ever allowed to pull those out of a Lightning component within Lex. You can think about a lot of benefits to having all of this state mutation happen in one spot. So I want to go over another trick that we learned, which is really the reusability of that parse method. So notice how I said parse my account's response? Let's look how many times we have that in here. So 4. So 4 things return essentially the same thing. So you can fetch my accounts. So a brand new instance of this component will go out on a net and look for the accounts it needs to display. It goes through this exact same thing. We can see when you create a contact, that exact same response body is returned. Delete contact, same thing. So what does that look like on the server side? Essentially, you have one getter for what you're returning, and then every setter returns a getter. So we're returning a list of accounts. where we've got a lot of stuff in here, including the subquery for contacts. So you can see here this select subquery is pulling down all the contacts. Okay, so when you look at it, we're really just adding and deleting contacts to this component. Add contact, return my accounts, delete contact, return my accounts. All of them return my accounts. It's all parsed the same way. You're not wasting a server-side round trip to say, okay, something changed, let's go look for more data. Okay, so we've seen a lot about how that works. We've seen the delete. We can step through one more real quick just so we're all on kind of the same page, but it will be very similar. Let's look at how we are handling the expansion of these accounts. So this plus, this minus. What happens when we refresh? It won't be persisted. It's a client-side only state modification. So what we're doing here is setting is expanded. So if you look on the account DOM component, you have two modes. You can be collapsed or you can be expanded. What tells the DOM component if it's expanded or collapsed? Something that the smart component knows about. So on the smart component, we have an is expanded attribute to every account component, and we're setting is expanded to true if the client-side state variable expanded account ID is equal to the account ID. So we just have one client-side attribute here on the smart component, expanded account ID. And then we're going to set that in our toggle account expanded method, which is fired from the on click of that plus or that minus. So exact same thing, except one layer up. We're going to get the generic event. We're going to set the parameters. Set the parameters of the generic event, which include the action type and the account ID. The action type in this case is going to be toggle account expanded. The payload's going to contain the account ID you'd like to toggle. Not rocket science, very expressive. If you read this, you know what's going on and you can figure out how it's consumed. So, toggle account expanded. You can see this is slightly more complicated just because you're toggling something, you're not just setting something. So if the current expanded account ID is the payload ID, you're actually setting it to null, else you're setting it to the payload value. But all this logic means if something goes wrong, you're logging right here, and there's only one spot this can be set. So that's a quick demo of the code. I want to go through some lessons learned and some pros and cons. So I'm biased, I really like this. The cons are there's lots of typing, and there's another con specific to Lightning components where component event bubbling is a little weird. The events are great, but they don't bubble like traditional DOM events, if you're familiar with that. Like a child bubbles to its parent, then its grandparent, great-grandparent. Lightning component events go from the component where the event happens, and they bubble to one spot, and they call it the facet provider. And I don't really know the naming, but it's essentially the top level of the component. And it provides facets, I guess. The pros are it's consistent. If you're working with a team, if you're working with a large amount of people, if you're trying to teach people how to do Lightning component dev, it's very organized. There's a pattern. You can follow the pattern, and when you're jumping between components and apps that your team makes, if everything's made like this, even though it's more typing, you're going to save a lot of time in your development just because you know exactly what's going on and your debuggability has improved so much. There's also possible gotchas and unknowns. We're in Lightning component world. There's some unknowns with what we're working on. Render speed could be a real issue as this scales. You're setting that one big state ball at the top and calling for a full re-render of the entire tree every time you make a change. In React land, you handle that via immutable data and the ability to quickly check if something has actually changed. I have heard one person at Salesforce speaking about this kind of immutable data state re-render problem, but I have not seen it in the wild, and I'm not sure how that's filtered down, especially to us ISVs or SIs doing our own components for clients. So lessons learned, state is bad, state is what screws your app up, minimize the things that change your state. If you can't do that, you have to make them really easy to debug, and you have to make it very obvious how everyone should be modifying state. And again, this isn't new, like this isn't any breakthrough or anything. This is applying proven concepts that front-end dev has been doing for years, and they're applying it to Lightning components, and it works pretty well. You're just transitioning to a different syntax, really. So we've got a lot of time. Does anyone have questions or stories or anything? No one? Yeah. I see that argument. I also see the problem of a flat folder structure within my Lightning component repo, and I'm trying to balance those. And I also took inspiration from essentially Flux, which does a very similar thing. You fire an event and it's consumed by every store, and there's a key in there that tells you, that identifies what's going on in the event. But yeah, if you're looking maybe in the Lightning component debugger, it will be slightly more difficult to identify the event. The plus side is you're not making a bunch of metadata for someone toggled something, you know? It's a balancing act. I see both ways, but as it grows, I could see having 1,000 events being just difficult to maybe find the proper event to fire, and you might be making dupes, that kind of stuff. Any other comments? Excuse me.
Application.
So these components will work in the Lightning App Builder. That's really just the interface you drop in, and every component's going to be handling its own events. Like that whole cross-component communication thing is interesting now with Locker service. You're essentially firing application-wide events if you want to do that. So what I would see for cross-component communication is another handler. Sorry, one sec. Another handler for application-wide events that impact the same state ball. And you'd be doing that very similar to what you do here. You're handling a generic event. What if you handled a generic application event? And when something happened that another component said, okay, if anyone else cares about this specific key, go do something. Did that cover it? Feel free to continue speaking.
My concern is that what I would prefer to do is write components that I can use as much as possible in as many places as possible. And my components are dependent on there being some smarter component above it in the context in which that component is used. And that's a little bit limiting because now I can't use that component everywhere. So that's what I was thinking. How would you manage it? It seems like it works great for apps, but how would you sort of...
Yeah, I think I get closer to what you're saying now. It is interesting. You do have that delineation between a smart component and a dumb component. That being said, it really depends what you want to call your smart component. That's really where you slice it and say, I'm at the top. If we want to reuse that dumb contact row component and another smart component, it'd be super quick to do. So a lot of your work is actually done in your dumb components. And a lot of that smart component work, while it would be duplicative, it would be pretty quick to do. But I do understand they're not all living on their own. The benefits of that is going to be doing things like your own batching of these server-side calls. You have more granularity on that, rather than relying on the boxcarring magic that generally works, but Apex is still one transaction. But, yeah. Anything else? All right.